Okay, let's define and kind of formalize the difference between something called a permutation and a combination. And this was before, this is a video that goes before talking about the second worksheet in counting, which is 8.2. All right, so first let's talk permutation. So a permutation is when order matters. So a different arrangement is a different outcome, in other words. And so let's take an example, and then we'll talk about some notation and a formula that is sometimes used. So the example would be, we'll do a very simple example. Say there are 5 books, and I want to arrange always signifies order of mattering. I want to arrange 3 of the books on a shelf. And how many ways can I do that? So 5 things to choose from, and I'm choosing 3 where order matters. So the notation for permutation is P. There's 5 to choose from, and I want to choose 3 of them. Another way, a calculator in particular shows this way. You've got the 5P3. And if we think about, before we even, have this notation, how would I do this problem if order matters? Well, there's 5 ways I choose the first book for the first spot, 4 ways I choose the next book for the next spot, and 3 ways I choose the final book for the third spot on the shelf. Well, formalizing this into, or thinking about this in terms of a formula, it is related to factorial, except we've cut some of the factorial off. So if we think about what we cut off, it would be 5 factorial, but we're missing the 2 and the 1. So we're dividing by 2 factorial. But another way to think about it, if I'm just going off the fact that it was 5P3, well, we could think about it as 5 factorial over 5 minus 3 factorial, which is how we got that 2 factorial that we cut off. So in general, for a permutation where order matters, you could use the following formula. And you don't have to. I mean, doing for this problem 5 times 4 times 3, perfectly fine. Or frankly, writing for me P53 is totally fine, or 5P3 is totally fine. But it is good to know, and some standardized tests and questions will require you to know the formula. So the formula in general, if I have N things, people, items, and I want to choose K of them, it's equal to N factorial over N minus K factorial. And that's how you would calculate a permutation. Okay, so, and by the way, something that's worth noting, because this does happen, that say I had N things or books, and I wanted to arrange all N of them. Well, using this formula, this would be N factorial over N minus N factorial, which is N factorial over 0 factorial. Well, by definition, in order to make these permutations work out, because we know if I have N things and I want to arrange all of them, that's just N factorial. 0 factorial actually equals 1. So that may be helpful at some point in time to know that 0 factorial equals 1, or else this formula would never make sense. Okay, that is a permutation. Let's move on to where order does not matter. And when order doesn't matter, it means a different arrangement of the same thing is not a different outcome. So the number of combinations of something is always less than the number of permutations. Okay, talk about this. So combinations, we just said order doesn't matter. And I'm going to go with this same example, except order not mattering. So the example would be, I have 5 books want to choose 3 of them. No mention of order here, so order presumably is not mattering. How many? Obviously, these are not full proper sentences, but okay. So in this case, the notation, my preferred notation, which I call the choose notation, is I've got 5 things, I'm choosing 3 of them. That signifies combination. Or you could do just like permutations, except have a C, 5, 3. Or you could say, just like on our calculator with permutation, except a C, 5C3. And if I think about what we did in last class, how I would solve this problem, and then we'll get it to the formula behind it, I would say, okay, it's like the permutation. So first I'm, getting how many ways can I choose the 5 books if order mattered, 3 books out of 5, 5 times 4 times 3, but I have to divide out the number of ways of arranging the 3 items. Well, it turns out that a combination, 5 choose 3 is actually equal to a permutation, because that 5 times 4 times 3 is just the permutation of if I have 5 things and I want to permutate 3 of them, divided by how many ways I could order those 3 things. So if that's the case, in terms of the actual full-on formula, in this particular instance, it would be 5 factorial divided by 5 minus 3 factorial, then divided by 3 factorial, but that is really ugly looking. So it is 5 factorial divided by 5 minus 3 factorial, 3 factorial. Because remember, divide by fractions multiplied by the reciprocal. So you're multiplying by 1 over 3 factorial. So in general, for a combination, if I've got n things, people, items, whatever, and I want to choose k of them, it's n factorial over n minus k factorial times k factorial. Again, sometimes that can be helpful. For me, and you're going to see in problems in 8.2 and the further lessons that I often just put answers in choose notation. I don't actually do it out. Okay, so that is just an intro to the difference between a permutation and combination.